Hi Trig students, this is part 2 of the study guide. This is going to cover chapters 8 and 9. So we're going to pick up on problem number 22. We start triangles, which I know some of you love and some of you hate, so hang in there. There's not many. So if you notice in this first triangle, it's a right triangle, which is really nice because we can use SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we have that information. We also have theta, so this is our point of view. This would be opposite, this would be adjacent, this would be hypotenuse over here, what we're going to call C. So the first thing we need to do is find C. So we know that a squared plus b squared is c squared, right? So we are just going to square both of those sides, just like that. We're going to have 16 plus 49 is c squared. And this is going to give me 65. Square root of 65 for my c. Okay, it's a strange value, but there we go. All right, well, we have our SOHCAHTOA, so we're able to find any of the 6 trig functions based on this right triangle. They want us to find, in this particular problem, cosecant and secant, okay? So cosecant is just the opposite of sine. So instead of looking at opposite over hypotenuse, we are going to find hypotenuse over the opposite. Okay, we're just going to flip it. Okay, or you could find sine opposite over hypotenuse. Once you find that, then flip that. So a couple of different options there. Okay, the hypotenuse is the square root of 65. We just found that. That's our C. Okay, and the opposite is going to be this side over here, which is 4. We can't reduce it. That's our answer. All right, next is secant. Secant is the reciprocal of cosine. So we could find cosine, which is adjacent over hypotenuse, and then flip that, or because this is adjacent over hypotenuse, we know secant is hypotenuse over adjacent. We found the hypotenuse, root of 65. Adjacent to theta is 7. Nothing to reduce there, and we're done. So make sure that you are able to do this. Make sure you're comfortable. What if it had asked for cotangent? Well, tangent is opposite over adjacent, so cotangent is adjacent over opposite. When I'm standing here at theta, my adjacent side is 7, my opposite side is 4. Cotangent would have been that, okay? And then, of course, if we had done sine or cosine, we would have had some rationalizing to do, but that's not needed here. All right, now we're going to move on to 2 word problems, okay? One involves a radio tower, so I'm going to draw a nice big tower. This tower is 180 feet tall, the whole tower, okay? A guy wire, and yes, it's called a guy wire. It's not a guide wire. I know that's a little fun fact for you. It's actually called a guy wire, is to be attached 12 feet from the top. So not from the top, we have to go down 12 feet from the top and attach a guy wire. And here's our ground. We're going to assume the radio tower is super straight, so we have a right angle. So this little piece here is 12, okay? And this guy wire is making an angle of 26 degrees with the ground. All right. What we would like to know is how long the guy wire here needs to be. This is what we're trying to find. So I'm just going to call it R. You could call it C. You could call it the hypotenuse, whatever it is you're looking for. All right. Well, I have an angle. I also have a side. If the whole thing is 180 and this piece is 12, I can do 180 minus 12 and get 168 as this little side here, okay? So if this is my angle and I have the opposite, and I would like to find the hypotenuse, look what we have. Sine is the opposite over hypotenuse. So if I take the sine of 26 degrees equals the opposite over the hypotenuse, I can solve for the hypotenuse. Now, remember, if what you want is in the top, you're good to go. But if what you want is in the bottom, you need to switch these. Remember, we could do the whole thing where we multiply this over here, we divide this over here. We did that in chapter 8, but what it really boils down to, the quick and dirty way, is to just switch these. Now, with triangles, please, please, please make sure you are in degree mode. I know this is a lot of going back and forth in your calculator between radians and degrees, but make sure you're in degree mode. So here we go. I'm still on the inverse from our earlier problem. So I'm going to go to mode, put it in degree. There we go. I'm going to do 168 divided by the sine of 26 because I'm already in degree mode. That is the length of my guy wire, and I want to round it to the nearest tenth, so 383.2. And this was feet, so this is feet. And that's what I'm looking for, okay? So you will have a radio tower, and you will need to find the length of that hypotenuse, that guy wire. You can do that. Don't panic over the word problems. There's one more. We have a tree, okay? Here's our tree. So I'm going to put it in. I'm not going to draw the whole tree. We'll just say this is the tree. Okay. And here's the ground. So we have a nice right angle again. Okay. The tree casts a shadow of 28 meters. And I think I've told you this before, but people do weird stuff with the shadow measurement. Are shadows floating in the air? Are shadows on the object itself? No, your shadow's on the ground. There's your 28, there's your shadow. Now, we're also gonna have a triangle here. This angle is 24 degrees. That's the elevation of the sun. It's the elevation, right? We're going up. So there's your degree, okay? What you wanna find is your tree. I'm gonna call him Y, okay? You're finding the tree. So I don't even need the hypotenuse because think about it. I have a degree, I want the opposite, and I have the adjacent. Well, it just so happens that the tangent of an angle is the opposite over the adjacent. That's the definition of tangent. Okay, now what I want is in the top, so I don't have to do anything at all except multiply these two together. So if I do 28 times the tangent of 24 and I round, I'm gonna come, it wants me to round to a whole number. I come up with 12 meters. So your two word problems are not difficult. They both involve right triangles. Just make sure that you understand those SOHCAHTOA relationships, okay? All right, let's move on to solving for triangles now. So solving for triangles is going to involve the law of sines and the law of cosines, right? We have both of those. Now, you are not gonna have that horrible angle side-side relationship, right? You're not gonna have that one. You don't have to worry about no triangle or two triangles or one triangle. You don't have to worry about that. We don't have it, okay? You also are not going to have a side-side-side situation to worry about, okay? So you're going to very straightforward have either angle, side angle, or angle, angle, side, okay? Or side angle, side. So you're not going to have either one of those situations that you have to deal with. This one is a very complicated law of cosines. This one is that annoying ambiguous case where we don't know what we have. You don't have to worry about those. All right, here we go. Solve the triangle. Well, if I have two angles, I can find the third because I know they should all add up to be 180, right? So B is going to be 61 degrees. I just take 180 minus both of those. Ta-da! Now I have all the information for B. And since I have all the information for one letter, I'm going to use the law of sines. Okay, and since I'm solving for a side, it doesn't matter which angle that I use here. So I'm going to solve for side A. Here's side A, here's side C. I'm going to solve for A. So sine of angle A on the bottom equals side B on the top and sine of angle B on the bottom. There we go. We're going to multiply and then divide. Okay, and we're still in degree mode. So I'm going to have sine of 76 times 12 divided by the sine of 61. And I get 13.31. There's my side A. I'm going to do the same thing for side C. I'm going to put it over sine of 43 degrees. I'm going to have side B on top and angle B on the bottom. Okay, I'm going to multiply and divide, and I come up with C is 9.36. And now my triangle is solved. So much nicer than your chapter 8 test. You don't have, a lot of complicated triangle things around there. All right, let's look at number 26. So this was an angle, side, angle, okay? Here we have an angle, angle, side, because my side's not in the middle. I can still find angle C very easily because I can do 180 minus 30 minus 50, and angle C is 100 degrees. It's a really badly drawn triangle, just pretend there, okay? All right, now I have all my information for B again, so I'm able to just jump right in and do my sides, okay? Side A over the sine of 50 degrees is going to be equal to 5 over the sine of 30 degrees. And this A is going to give me 7.66. There we go. Now I'm going to solve for side C. I put it on top because that's what I want. Over sine of 100 degrees equals 5 over the sine of 30 degrees. And my C is 9.85. And there we go, we solved. Okay, so very simple triangle issues on this test. Nothing that's too difficult. All right, that brings us to 27. Okay, we don't have a triangle. So solve the triangle. Here we go. I'm gonna draw a nice triangle. I'm gonna do my standard labeling. I didn't like the labeling of those other triangles, but that's how they had them labeled. Okay, so side A is 6, side B is 9, C is 130 degrees. So in this case, I have a side, angle, side triangle. Okay, I cannot use law of sines here. I'm not able to do that because I don't have all of one letter and I don't have a way to find these two angles right away. So in this situation, you're gonna have the law of cosines, okay? So you're solving for the side you don't have. In that case, it's c squared, okay? That's gonna equal the other two sides squared and added together, because remember, the Pythagorean theorem comes from the law of cosines. So there we go. Now we're also going to have minus 2 of each one of these sides times the cosine of the angle of the side that we're looking for. Okay, so remember there's two other versions of this particular formula. If you need them written down, here they are. okay? Because I don't know what kind of situation you're gonna get into or exactly what your triangle is gonna look like, but there they all are in case you need them, okay? All right, so I have all this information over here. So c squared is gonna be a squared, which is 36, plus b squared, which is 81, minus 2 times 6 times 9, because that's a times b, times the cosine of 130 degrees, okay? You don't have to, but if you clean it up a little bit, this is what we're dealing with, okay? We'll put that right into our calculator. So I'm gonna have 36 plus 81 minus 108 cosine of 130. That's c squared, 186.42. Now I don't want c squared, I want the square root. When I take the square root, I get 13.65. There we go. Now that I have all the information for c, I'm going to switch to the law of sines. Now that I have all the information. Now this is where you have to be careful. I can only use the law of sines with the smallest angle, okay? So would that be angle A, who has a side of 6, or angle B, who has a side of 9? That would be angle A because the side is smaller, right? So I'm trying to find angle A, so he goes on top over his side, okay? I have all the information for C, so that's who goes on the other side. All right, I'm gonna multiply and I'm gonna divide. Now that's gonna give me sine of A. That's not what I'm looking for. There we go, I get 0.3367. In order to get just A, I have to take the inverse now. So I'm gonna do second sine 0.3367. Don't forget that you have to take the inverse so that you get the angle. And there's angle A, okay? Now that I've done that, finding angle B is easy, okay? I'm completely out of room, by the way, so I'm gonna just go like this. But angle B is gonna be 180 degrees minus 130, right? Minus 19.68. And angle B is gonna be 30.3 degrees. And there we go, okay? Oh, 3.2, sorry, 3.2. Okay, so that was kind of a long one. I didn't give us a whole lot of room there, but you had to start with law of cosines to find the side you don't have, whichever side that might be. Then you will have all the information for one of the letters. Switch to the law of sines, but find the smallest angle, which would be across from the smallest side. Find that angle. Don't forget to use inverse when you get down to this point. And then do B equals 180 minus those other two sides to get your third side. That's the extent of your triangles. Now there is one area question that I forgot to put here with the triangle, so it's at the end. It's number 42. So we'll go back to triangles one more time at the very end. It's not Heron's formula, it's just the side angle side formula. So we'll go there in a little bit. All right, let's go to chapter 9 now. Everyone seemed to do so well on chapter 9, which thrills me. So I don't think you'll have any trouble, but you do have quite a few of these questions that go back and forth between polar coordinates and rectangular coordinates. So we just want to make sure you're comfortable with those. Okay, these are polar coordinates. It tells me that. So r is 4, theta is 3 pi over 4. Okay, let's see what quadrant we're in. All right, if I go to my unit circle, 3 pi over 4 is in quadrant 2. This r is positive, so I would be hopping up 4 spaces on here. So I'm going to be in quadrant 2, okay? I'm going to be up here in quadrant 2. Perfect. That means my rectangular point should also be in quadrant 2. All right. Okay, so to find our rectangular point, x is r cosine theta, y is r sine theta. And I'm just going to plug it right in. R is 4, cosine of 3 pi over 4. Y is r is 4 times the sine of 3 pi over 4. Okay, now let's go figure out the point for 3 pi over 4. Cosine is negative root of 2 over 2. Sine is positive root of 2 over 2. Whoops, I went my paper. Is that straight again? Maybe? Okay. All right, so cosine is negative root of 2 over 2. This is positive root of 2 over 2. We're going to reduce a little bit. We get negative 2 root of 2, and y is positive 2 root of 2, which means my rectangular point is this. Now, question is this in quadrant 2? Well, I have a negative x and a positive y. Yep, check, sure is. Never hurts to check that. Make sure you're in the right quadrant. Okay, let's look at number 29. Okay, what quadrant am I in for this guy? Well, my r is negative, and my theta is 2 pi over 3. All right, let's find 2 pi over 3. 2 pi over 3 is right here in quadrant 2. If my r was positive, I'd be in quadrant 2, but my r is negative. So I'm not going to be in quadrant 2. I'm going to be in quadrant 4 because I'm actually going to be down here like this because of my negative r. So 2 pi over 3 is right here. But remember, it goes all the way through this. We've got like a 3D plane here. And I'm not going 1, 2, 3 positive. I'm going 1, 2, 3 negative. So I'm actually in quadrant 4. That's where I need to make sure I end up. So we need to check that and be really careful about that. Okay, this was quadrant 2. I had a positive r. Okay. All right, so I'm going to have x equals r cosine 2 pi over 3. Y equals r sine 2 pi over 3. All right, 2 pi over 3 gives me a cosine of negative 1/2 and a sine of root of 3 over 2. Okay, so this is going to be negative 1/2, and this is root of 3 over 2. Okay, clean this up. My x is a positive 3/2. My y is a negative 3 root of 3 over 2. Last thing we want to do is just make sure we are in quadrant 4. So this is a positive x and a negative y. Yep, quadrant 4, check. That is the correct rectangular coordinate. Okay, a few more of these. All right, just this page here, and then we're going to switch up a little bit. All right, so again, these are polar coordinates. Be careful because, boy, those look a lot like rectangular coordinates. So we had to read the question. Okay, let's see if we can figure out where we are. All right, well, 0 degrees is right here, but I'm not going forward 13. I'm going backwards 13. So I'm somewhere way back here, right? So that's where I am. I'm like the negative x-axis. Okay, let's find the rectangular coordinates. My x is going to be r times cosine of 0. My y is going to be r times the sine of 0. Okay, let's go to our unit circle. Here's 0. Cosine is 1, sine is 0. Cosine 1, sine 0. X is going to be negative 13. Y is going to be 0. Anything times 0 is 0. So I'm actually looking for the point negative 13, 0, which is super strange. Remember, sometimes, every once in a great while, your polar point and your rectangular point are exactly the same. So there we go. All right. Does this match? Sure. If I go to the left negative 13 and I don't go up or down, I'm in the same place. So that makes sense. All right. Here we go. The rectangular coordinates of a point, x, y. Find the polar coordinate in radians. Okay, we want to make sure we're in radians now. Well, let's figure out what quadrant we're in. I have a negative x and a positive y. I'm in quad 2. Okay. Now, in order to get my theta, I'm going to use the relationship that tan theta is y over x. Or in other words, 2 over negative 2, my tan theta is negative 1. What I'm really looking at is where in quad 2 is tan equal to negative 1. Okay, well, if I go over here in quad 2, in order for tangent to be negative 1, x and y have to be the same value, but the opposite sign. That puts me right here. And that radian value is 3 pi over 4. Oh, boy, it just really wants to come with that unit circle, doesn't it? Okay, so theta is 3 pi over 4. Okay, now we're going to need an r. Well, we also know r squared is x squared plus y squared. So I'm going to have negative 2 squared plus positive 2 squared. R is going to give me square root of 8. I can reduce that to 2 root of 2. So my polar point is 2 root of 2, comma, 3 pi over 4. We need to make sure that's the correct quadrant. So 3 pi over 4 is right here in quadrant 2, and my r is positive 2 root of 2, which would still leave me in quadrant 2. Yep, that's where I'm supposed to be. So I'm good to go. All right, very last one. I have a rectangular coordinate. There's my x and my y. Let's figure out what quadrant I'm in. I have a negative x and I have a negative y. So I'm down here in quad 3 this time. Okay. Tan theta is y over x. So negative 1 over negative root of 3. That's just 1 over root of 3. Okay. What I'm looking for is where in quad 3 is tangent equal to 1 over root of 3. Now look at that root of 3 placement. That root of 3 placement means, because this is y over x, that I'm looking for an x with a root of 3 in it. That's what that boils down to. Okay, so tangent in quadrant 3 with an x with a root of 3. Okay, quadrant 3, here are my x values. This 7 pi over 6 has a root of 3 as part of x. Okay, so if we just want to test that out, 7 pi over 3, nope, made that up. 7 pi over 6 is equal to this point. If I were to take the tangent of 7 pi over 6, I would get y over x. Denominators cancel, negative signs cancel. I get 1 over root of 3. That's exactly what I was looking for. So, turns out my theta is 7 pi over 6. Now, I need my r. Okay, r squared is going to equal x squared. That's a negative root of 3 squared plus a negative 1 squared. Okay, can you see that? Did it go off the page? You're okay. All right, so r squared equals negative root of 3 squared is actually just 3. And this is a 1. R squared is 4. If I take the square root of both sides, r is a nice little 2. So my polar coordinate is 2, 7 pi over 6. Now if I want to check and just make sure I'm in quadrant 3 there, here's 7 pi over 6, I'm in quadrant 3, and my r is positive 2, so I'm staying there in quadrant 3. So that is perfect. Ta-da! Okay, all right, here we go. Now we're moving on, getting really close here. Number 33 and number 34 have us identifying polar equations. Now there's only 2 polar equations you're going to need to be familiar with, okay? And those polar equations are what you see right here. Now I want you to be careful with these because I will tell you there were a lot of you who mixed these guys up on your test. You got them confused because they look so similar, okay? Look at the difference here. I'm not talking about cosine and sine. There's a number in front and there's a number with theta. How are you going to know they're different? This has an r squared. This is just an r. That is the difference. If it's an r squared, you have a lemniscate. What am I doing? I'm writing a K. Lemniscate. Okay, you have a lemniscate. There you go. Okay, because his formula is r squared equals a squared cosine 2 theta, or r squared equals a squared sine 2 theta. Those are the 2 possibilities. A is the petal length. Now there's only 2 petals with a lemniscate. There's only 2 because it's like that infinity sign, right? So if I take the square root of 9, my petal length here is 3. The only question is going to be, is this a horizontal lemniscate or is this a diagonal? Cosine means horizontal. Sine means at a 45-degree angle. So you're going to identify this as a lemniscate. Then you're going to look at your equation and pick out of the 4 graphs the one that makes sense. This particular one is going to be horizontal with a petal length of 3. You may very well have the diagonal as well, so be really careful on that, okay? But that's what all you're going to have to do. Lemniscate, pick your graph. Okay, next graph. This is just an R. If it is just an R, you have a rose. He's going to look like this. Or he may have a cosine there instead, right? Okay, he may have a cosine. That's okay too. All that's going to do is kind of describe how the petal spacing works, but that's not really important. What you're going to have, and here, oh, why did I put a 2? This should be an A. Okay, so A, again, is your petal length. You don't have to take the square root of it like you do up here with the lemniscate. So my petal length in this case is 2. I'm not worried about sine or cosine. What I am worried about is n. I want to know how many petals you have. If n is odd, okay, if n is odd, then n equals your number of petals. If n is even, then you have to do 2 times n to get your number of petals. That's the difference, okay? And you don't really have to know the spacing or any of that stuff. You just have to be aware of your n. Okay, so in this case, my petal length is 2. My n is odd, so I don't have to multiply it. I have 3 petals, okay? And if you just kind of keep in mind that they want to be as far away as possible from one another, that's what we end up with, okay? So make sure plane R rows, R squared lemniscate. If it is, when you see your N here, make sure that you know if it's odd, that's the number of petals. If it's even, you multiply it by 2. Okay, and those are the only 2 polar equations you need to worry about. All right, let's move on to some complex plane. Okay, in the complex plane, this is how we write a complex number in polar form. We have R in the front, we have our theta, and then we have I sine theta. Okay, this one wants you to find ZW. Easy enough. ZW means we're going to multiply these R's together. So we're going to have 3 times 21. If you want to go ahead and write 63, you go for it. Whoops, not an equal. Okay, then we're going to have cosine. We're going to take both of these thetas and we're going to add them together. Plus I sine of 50 plus 25. There we go. Okay, so you're going to look for the answer that is 63 cosine of 75 degrees plus I of sine of 75 degrees. And that's it, because it wants your answer to stay in polar form. Okay, multiply your R's, add your thetas. That's it. All right, I don't believe you have one like 36, but it wouldn't hurt for us to go ahead and do it just to make sure. And then that's all you have for complex plane, and we will move along to vectors. We just have a few more vectors, and then I want to do the area of a triangle just to make sure that you're comfortable. Okay, so here we're going to do ZW and Z divided by W. We're going to do both. All right, now you know this means we multiply the R's, add the thetas. Sorry, like this. This one means divide the R's, subtract the thetas. So we need to make sure these thetas have the same denominator. Well, 9 and 13 don't have anything in common unless you multiply them together. And then they have the lovely 117 in common. So if I multiply top and bottom by 13, here I would multiply top and bottom by 9. We've just rewritten it. That's all. Okay, so 13 pi over 117 is now Z's theta. 9 pi over 117 is now W's theta. So if I'm going to multiply these together, I'm going to multiply their R's, and then I'm going to take their thetas and I'm going to add them. You probably don't even need this little intermediate step here. Just wanted to make sure you understood what was happening. Okay, so Z times W is going to be 49 cosine of 22 pi over 117 plus I sine of 22 pi over 117. That's your answer. Okay, Z divided by W is going to be 7 divided by 7. That's just a 1. We don't even need the 1. Cosine, we're going to subtract these two now. 13 pi over 117 minus 9 pi over 117 is 4 pi over 117. And there's your answer. And again, I just divided that 7 divided by 7, and I subtracted my thetas. And there we go. All right, that brings us to vectors, okay? All right, so number 37, write the vector V in the form AI plus BJ. It gives the magnitude and it gives the angle. Okay, here's the equation you're gonna need. The magnitude times that little form right there. Okay, So here we go. Our magnitude is 20 times the cosine of 120i plus the sine of 120j. And then we're just going to multiply. Oh, we're not multiplying yet. Sorry, guys. I got ahead of the game. We need to figure out what these values are in there. We're going to go to 120 degrees on our unit circle. Here we are. My cosine is -1/2. My sine is √3/2. My cosine is -1/2. Don't forget your I. My sine is √3/2. Don't forget your j. Now we're going to distribute. I'm going to get -10i plus 10 √3j. And there we go. There's our vector. Okay, one more of these, just because it's a little strange. Okay, we want to make sure you're comfortable with it. 2 more pages and we're all done. Same directions here, magnitude of 20, but look at our angle this time. Our angle is 0, which is super weird. So we're going to make sure we're comfortable with that. All right, so we have our formula from the page before. We're going to have the magnitude times cosine of alpha I plus sine of alpha j. Okay. Now we're going to go to our unit circle to 0 degrees. Cosine is 1, sine is 0. Cosine is 1, don't forget your I. Sine is 0, don't forget your j. We'll push that 20 through there. We're going to get 20i, and that's just going to be 0. There's my vector. Okay, so that one's a little strange. We didn't have a j component because anything times 0 is 0. All right, 39 wants the angle between the 2 vectors given. Okay, so that's going to be cosine theta equals the dot product. There aren't any questions that explicitly ask you for the dot product, but you are going to have to use the dot product on several problems, so make sure you're comfortable doing that. Divided by the magnitude of each vector, and again, you're going to have to be able to do that as well. Okay, so let's find the dot product of this. All right, so my dot product is supposed to be the coefficients of I, well, this doesn't even have an I, so that's 0, times the coefficient of this I, which is -1, plus coefficient of j times the coefficient of that j, which they don't even have one, so it's 0. This is going to be 0 plus 0. My dot product is 0. So do you remember what that means? That means 2 things. Number 1, it means they're orthogonal. Number 2, what's the angle between 2 orthogonal vectors? 90 degrees. You can stop right now and put 90 degrees down because they're perpendicular. Or you can keep going, okay? If you wanted to keep going just for practice, the magnitude of V is going to be 0 squared, because that's the I coefficient, plus 12 squared, that's the J coefficient. It's going to give you a 12. Magnitude of W, I coefficient, it's -1. J coefficient 0, it's going to be a magnitude of 1. This cosine theta is going to have a dot product of 0 times 12 times 1, that's just 0. And what's the inverse cosine of 0? What's theta where cosine is 0? Well, cosine is 0 right up here at 90 degrees because we're only looking at this upper portion when we talk about vector angles. And so that would be 90 degrees. But you knew that immediately once you knew that dot product. Okay, number 40. State whether the vectors are parallel, okay, orthogonal, or neither. Orthogonal is going to give us a dot product of 0, right? Parallel is going to mean that we can take a value and multiply it by 1 and get exactly the other, okay? So first thing I would always do is try the dot product, see what it comes out to be. Okay, so we're going to take 8 times 7 plus 7 times negative 8. This is going to be 56 minus 56. That's a dot product of 0, and that means those guys are orthogonal. There we go. Okay, last page. Look at there. We're almost done. Okay, number 41. Again, state whether the vectors are parallel, orthogonal, or neither. Okay, well, first thing we need to do is be able to rule out orthogonal. So let's do a dot product. We're going to take negative 3 times 21 plus negative 4 times 28. Well, that is not going to be a 0. Let's see. This would be negative 63, and this would be a negative 112. That's a negative 175. All that tells us is we are not orthogonal. That's all it tells us. Now let's check for parallel. Parallel means that we are going to have one vector, and we're going to see if there's a number we can multiply by it to get the other vector. What can I multiply by v to make it equal w? Well, to go from negative 3 to 21, I could multiply by a negative 7. Then the test is, can I also do it with the j coefficient? Negative 4 times negative 7 is positive 28. So yep, that totally works. This is parallel, okay? So as long as you can take one of the vectors and multiply both components by a number and get both components of the other vector, you are parallel. So make sure you understand that. All right, last question has to do with triangles. Let's draw it. Okay, I'm going to go back to my standard labeling. Here I have side B is 1, side C is 5, and A is 75 degrees. This is a side angle side triangle. Okay, this means I can find the area using that side angle side formula. So you do not have to worry about Heron's formula. Remember, that's the one with the semi-perimeter, where you had to add up the perimeter, divide by 2, and then you had to use that under a square root. You do not have to do that. Your area is going to end up being 1/2 BC times the sine of A, or you could have 1/2 A times B sine of C, or you could have the area 1/2 AC times the sine of B. Basically, what it boils down to is that whatever two sides you get, multiply them together, multiply them by the sine of the angle, divide by 2. Okay, so in this case, I have sides B and C and angle A, so I'm using this. I'm going to have 1/2 times 1 times 5 times the sine of 75 degrees. Put that all in your calculator, and you get 2.41. You don't have to worry about units, but area is square area, so they would be squared. That is your final exam. And then the rest of these pages, those are just the answers. Okay, that has what you need. So be sure to look this over. Don't, take it as the absolute thing, because there are so many pooled questions from that 93 question pool, but this will definitely get you an A on the final exam, as long as you're thinking and you're taking your time and you're looking over and just kind of remembering all that stuff that you know. And I miss you guys so much. I'm sorry I didn't get a chance to say goodbye to you, but I hope you have a great summer. And I will be sending you an email once all the grades have been put in to let you know that everything is final. So, all right, do your best, and I miss you. Bye-bye.